Okay, so I'm going to record this lesson, and hopefully it'll be something that can help you do well on the test on Friday. The first one on the vector practice problems talks about Maxwell the man, and Maxwell the man is riding his bicycle since he recently lost his license in a nasty collision. He needs to head on a bearing of 40 degrees for 2 meters and then move 122-degree bearing for 4 meters. What are the magnitude and direction of his resulting displacement? So I always make a sketch. Doesn't look like much, but I always make a sketch. So let's see if I can sketch this for you. So he went out that way, 2 meters. And this angle with the x-axis was 40 degrees because if you think about pilot's bearing, there's 0 and 90. So this little angle right here is 40. And then again, I can come out here and draw a new set of quadrants. And so 122 would be over here, 4 meters. So this whole thing is 122 right there. Then this little small angle is 32 degrees. Okay. And I know that this 2.0 meters is actually made up of an x component and a y component. This is y and this is x. On the fast check, people just put letters crazy, calling this y and this is x. This is y. This is x because it's on the x-axis. This is y because it's on the y-axis. And then I did the same thing here. Here's another y, and here's another x. So I'm going to make a t-chart, x, y. So this one is going to be the cosine of 40 degrees times 2.0 meters. And it is to the right, so I'm going to call it a positive. And when I did that calculation, I got 1.53 meters. 1.53 meters. So I'm going to write it in the chart. This is going to be, this y is going to be the sine of 20 degrees, 40 degrees, hello, sine of 40 degrees times 1.5 meters. Well, what if we try again to get the right thing? So this is going to be the sine of 40 degrees times 2 meters. So when I did that, I got a positive 1.29 for my y component. So I finished with the first leg of the trip. Now I'm going to go do the second leg of the trip. So this is going to be cosine of 32 degrees times the hypotenuse of 4. That's a positive y. And that positive y, I got 3.39 meters. And then this x, I said, is the sine of 32 degrees times 4.0 meters. And in this case, the sign is to the left, so it's going to be a negative. And when I did that, I got 2.12 meters. So now I'm going to add them up. Well, a negative 2.12 and a positive 1.53 is going to give me a negative 0.59. And the negative is important because it tells me it's to the left. My y's, when I add them up, I get 4.68 meters. So I need to find his displacement using a right triangle that has a leg to the right, to the left because it's negative, that's 0.59. And then it has a very tall leg straight up because it's positive y, so that's 4.68 meters. I am looking for this thing right here and that angle. I always want the angle where the two tails come together, always, always, always. So I'm going to say that the displacement, or the resultant, I guess I could call it, is the square root of 0.59 meters squared plus 4.68 meters squared. And when I did that, my R came out to be 4.72 meters. Now I need that angle, so I'm going to know that it's a very large angle because it's a very tall vertical distance. So I'm going to say the tangent of theta is equal to 4.68 over 0.59. And when I did that, I got theta to be 82.8 degrees. And I'm going to say that that is north of west. I could also do the pilot's bearing because from here over to here, that starts at 0. That right there would be the remaining of 180, so 180 degrees for the whole line, minus that theta of 82.8. Gives me a pilot's bearing of 97.2 degrees. Or if I didn't want to do it that way, I could say that it is 7.2 degrees west of north. Where in the world did that come from? We'll look at it. If this is north, this little bitty skinny angle right here is going to be the 7.2 degrees west of north. So this works. If you don't like that, this works. If you don't like that, this works. Pick and choose what you like. So there's the very first one. Okay, let's roll on down and see if we can do the second one. You know you can pause this anytime you think I'm moving too fast. Okay, the second one says that your favorite aunt, see you later, is found a distance of 25 meters from her colony in the direction of 210. Okay, so 210 is in the third quadrant, so she's down here, 25.0 meters. The x displacement makes a 30 degree. How in the world did I get that? Well, if this is 210, x is 180 over in this direction. So 180 to 210 tells me 30 degrees. There's my y, and again, label them correctly. And they want to know the westward and southward components. Yeah, so how far south and how far west. Well, if I want to do the west, I'm going to say the cosine of 30 degrees is equal to x over 25 meters. So when I did that, that's 0.866 times 25.0. And when I did it on my little trusty TI calculator, I got 21.7 meters west. There's my west. My southerly is going to be the sine of 30 degrees is equal to y over 25.0. So y is going to be 12.5. And number 2 is done. Yippee skippy. All right, let's move on to number 3. So here's number 3. Number 3 says, the buñuelo is a Mexican dessert. You and your closest friend are both hungry and decide to pull on the dessert simultaneously. If you pull with a force of 30 pounds in a direction of 30 degrees. So here's you, 30 pounds, 30 degree pilot bearing. And your friend is going to pull on the buñuelo with a force of 20 pounds in a direction of 140. So 140 is over here. 20 pounds is a little less. I'm going to make that vector be a little bit shorter. If this is 140, then I know that there's my x and my y. There's my x. I'm going to use red, doesn't seem to want to, there we go. There's my x, and there's my y. They want to know the resultant force. So in other words, they want the sum of those two forces. So again, we have a lovely little table here. I think some people call it a T-chart. If this is a bearing of 30, that angle is 30. So this x is going to be cosine of 30 degrees times 30 pounds. This y is going to be the sine of 30 degrees times 30 pounds. Okay, so cosine of 30 degrees times 30 pounds is going to wind up being, according to my calculation, 25.98, or we'll just call it 26 pounds. And it's to the right, so it's a positive 26 pounds. This is sine of 30 is a half, half of 30 is 15, so that's 15 pounds straight up, so it's positive also. Over here on this side, 140 to 180 means this angle here is 40 degrees. So I'm going to say that this x is the cosine of 40 degrees times 20 pounds. And when I did cosine of 40 degrees times 20 pounds, I got 15.32 pounds. When I put it in my chart, I'm going to make it negative because it's to the left. Oops. This y is going to be the sine of 40 degrees times 20 pounds. So sine of 40 degrees times 20 pounds is going to be 12.86. So that's a positive 12.86 pounds. So now I'm going to do the addition of the XY chart. So 26 plus 15.32 is, I believe, 10.68. And this one is going to be 27.86. So now I'm going to draw my right triangle. Both of these are positive. So that would put a leg this way of 10.68 pounds. And a leg this way of 27.86 pounds. And we're going to pretend that that's a right angle right there. And so I'm going to connect the beginning with the end. Remember, I always want the two tails together and the two heads together. There's my theta. So R is going to be the square root of 10.68 pounds squared plus 27.86 pounds squared. So when I did that math, I got 29.83 pounds. Now I need the direction, so I'm going to find that theta. Well, tan theta is equal to 27.86 over 10.68. So when I did that, I got my theta to be 69 degrees. And that's pilot's bearing. You could say it's 69 degrees north of east if you liked. Or you could also say that it was 21 degrees east of north. I believe that completes number 3. Let me see how I am for time. We're going to try one more. Actually, we're going to stop and then we'll do the rest.